Welcome learners to module 1, that is energy sources. In this enlightening journey through energy science, we will explore the fundamental concepts and basic principles that power our world. This module serves as a gateway to understanding the diverse forms of energy that surrounds us and fuel our modern civilization. From traditional fossil fuels to cutting-edge renewable sources, we will review and analyze the full spectrum of energy options available today. By the end of this module, you will gain a comprehensive understanding of energy's significance, its impact on the environment, and the exciting possibilities that lie ahead in our journey for a sustainable future. So, let us embark on this learning adventure together and unravel the mysteries of energy that shape our lives and the world around us. So, let us begin with this picture. As you can see, a father is telling his son about their energy scenario. It might seem irrelevant now, but it may well become the truth after a few decades. The status of energy might reach such a state that a father will have to explain to his son about previous energy scenario. Our current ease of living and technology might become just a story. Without energy, life would come to a halt. As we know, energy is the driving force that powers everything around us, from the lights that brighten our homes to the machines that makes our lives easier. Without energy, there would be no movement, no communication, and no progress. The absence of energy would plunge us into darkness and limit our ability to meet even the most basic needs. If we want to leave something good for our future generations, we must appreciate the value of energy and use it wisely and sustainably without harming our planet. So, dear learner, through this course, we want you to become aware of current energy scenario and the advancement in green energy technology. We aim to prepare you to work in this field and research new breakthroughs for sustainable energy. Today's module will introduce energy, its types and major sources. I will also tell you about the Energy Conservation Act before broad classification and applications of energy. So, let us begin with today's learning. First of all, what is energy? The capacity to do work is energy. We need energy to power our homes, schools and workplaces, to keep the lights on and stay connected. Our vehicles, machinery and technology all rely on energy to function efficiently. From cooking our meals to running industries, energy is a crucial part of our daily lives. As our population grows and technology advances, the demand for energy continues to rise. Therefore, it is essential for us to explore and embrace sustainable energy sources to meet our needs, while preserving the health of our planet for future generations. The word energy is taken from energia, which is derived from the Greek language, where en means in and ergon means work, activity or operation. Therefore, the term energy represents in work or in process. The most basic definition of energy states that energy is the capacity to do work. This statement explains energy as the ability of a physical system to perform work. In the context of physics, work refers to the application of a force over a distance to move an object. Energy is what allows this work to be done. When a physical system processes energy, it has the potential to exert a force and it causes a motion or changes in its surrounding. For example, think of a car. The fuel in the car's tank contains chemical energy. When the engine converts the chemical energy into mechanical energy, the car can do work by moving forward. In this case, energy is transferred from the fuel to the car's engine, which enables it to perform the work of propelling the car. In order for an object to perform work, it must receive energy in some form. When energy is transferred to an object, it gains ability to do work. For instance, to lift an object, you must transfer energy to it by applying a force. This energy allows the object to overcome the force of gravity and move upward. When energy is transferred from one object to another, the amount of energy transferred can be quantified. This shows that energy has quantitative property. The unit of energy in MKS, that is meter kilogram second system, is the joule. The joule is the same unit of energy in both the SI and MKS system. It is defined as the amount of energy transferred when a force of 1 Newton is applied to move an object 1 meter in the direction of the force. Mathematically, it can be represented as 1 joule is equal to 1 Newton into 1 meter. In terms of SI base units, the joule can be expressed as 1 joule equals to 1 kilogram per meter square second square. The CGS, that is centimeter gram second system, on the other hand, uses the unit erg for energy, and 1 erg is equal to 10 raised to minus 7 joules, and it is defined as the amount of work done by a force on one dyne, which is the CGS unit of force acting on an object and displacing it by 1 centimeter. Mathematically, it can be expressed as 1 erg equals to 1 dyne 1 centimeter. So, dear learner, we may summarize that in SI and MKS system, energy is measured in joules, and in CGS system, energy is measured in ergs. There is one other unit of energy which is calorie, taken from the concept of heat energy, and 1 calorie is equal to 4.184 joules. So, now let us discuss the various types of energy. First one is mechanical energy. Mechanical energy is the sum of kinetic energy and potential energy of an object or a system due to its motion or position. Next is thermal energy. Thermal energy is the internal energy of a substance due to the random motion of its atom and molecules. It is associated with temperature and represents the total kinetic energy of all the particles within the system. Heating an object increases its thermal energy, causing its particles to move more strongly. Next is sonic or sound energy. Sound energy is a type of mechanical energy caused by the vibration of particles in a medium such as air or water. These vibrations create pressure waves that propagate as sound waves. Our ears detect these sound waves and perceive them as sound. Next is chemical energy. Chemical energy is a form of potential energy stored in the bonds of chemical compounds. It is released or absorbed during the chemical reactions. When chemical bonds are broken, energy is released, and when new bonds form, energy is absorbed. For example, the chemical energy in gasoline is converted to kinetic energy when it undergoes combustion in an engine. Next is nuclear energy. Nuclear energy is the energy stored within the nucleus of an atom. It is released through nuclear reactions such as nuclear fission, splitting of atomic nuclei, or nuclear fission, that is combining of atomic nuclei. Nuclear power plants use nuclear reactions to produce heat, which is then converted into electricity. Then electromagnetic energy. Electromagnetic energy is a type of energy carried by electromagnetic waves such as light, radio waves, microwaves and X-rays. It includes both visible and non-visible forms of radiation. Electromagnetic energy can transfer energy and information across space. Next one is gravitational energy. Gravitational energy is a type of potential energy associated with an object's position in a gravitational field. The higher an object is above the ground, the more gravitational potential energy is possessed. Then potential energy. Potential energy is the energy stored in an object or system due to its position or configuration. For example, energy is stored in a stressed or compressed materials like a stretched rubber band. Next one is kinetic energy. As mentioned earlier, kinetic energy is the energy an object possesses due to its motion. The amount of kinetic energy depends on the object's mass and its velocity. For example, a moving car or a flying airplane has a kinetic energy. Next is ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom or molecule, resulting in the formation of an ion. It is a characteristic property of elements and is essential in understanding chemical bonding and reactivity. Now, major energy sources, primary and secondary energy sources are terms used to categorize different types of energy based on their origin and availability. Let us explain each of them in detail with examples. Primary energy sources are natural resources directly obtained from the environment. These sources are in their raw and unconverted form and serve as basis for producing other forms of energy that we use in our daily lives. Primary energy sources are considered inexhaustible or renewable if they can be naturally restocked within a short period. They are classified into two main categories. First one is renewable energy sources and another is non-renewable energy sources. Secondary energy sources are derived from the conversion of primary energy sources into more convenient and usable forms. These are the forms of energy that we directly use in our everyday activities. Secondary energy sources are produced through various processes, usually involving the transformation of primary energy sources. Some common examples include electricity, gasoline, diesel, propane and biofuels. To summarize, primary sources are the raw natural resources that serves as the foundation of energy production, while secondary energy sources are the converted and more practical forms of energy that we directly use in our daily lives. The transformation of primary to secondary energy sources is essential to meet our energy demand efficiently and sustainably. Next is major classification of energy. As we have already seen the primary and secondary sources of energy, let us further categorize these sources into commercial and non-commercial sources of energy. The commercial sources of energy include fossil fuels, that is coal, oil and natural gas, and nuclear power, while the non-commercial sources of energy are biomass, firewood, charcoal, cow dung and agriculture waste. If we talk about energy classification, energy can be broadly classified into two main categories, that is renewable energy and non-renewable energy. All the conventional energy sources like coal, oil and natural gas fall under non-renewable sources of energy. Renewable energy sources can be also divided into conventional and non-conventional sources. In conventional sources of energy, hydropower comes into the picture. Hydropower can be harnessed from three types of hydro stations, that is mini hydropower plant giving output in the range of 100 kilowatt to 1 megawatt, then a small hydro plant having capacity of 1 megawatt, then a small hydropower plant having capacity of 1 megawatt to 10 to 30 megawatt, and large hydro plant which is used for more than 30 megawatt generation capacity. Non-conventional renewable energy sources can be subcategorized as solar, wind, biomass, ocean thermal energy conversion, tidal, wave energy, hydrogen, geothermal, fuel cell and so on. Non-renewable energy may be classified as coal based system, gas based system and nuclear based energy systems. The coal based systems are divided into three subcategories that falls under the thermal power plants. First one is subcritical plant, second one is supercritical plant and third one is the ultra supercritical system. These plants operate under varying pressure levels. Gas based systems are also divided in three classes, that is open cycle gas turbine, combined cycle gas turbine and reciprocating engine based systems. The last category is nuclear energy based system, which is further classified as breeder and non-breeder reactors. In breeder reactor, nuclear power plants like pressurized water reactor, boiling water reactor and advanced gas cooled reactor are commonly used. In non-breeder reactor type, fast breeder reactor and thermal breeder reactor are used. All these systems exist in the physical world and play a fundamental role in understanding and explaining energy transformation and interactions. For efficient and effective use of energy and its conservation, the Energy Conservation Act of 2001 was ratified in India. This comprehensive regulation aims to promote sustainable energy practices, reduces energy consumption and optimize the utilization of resources. Except Jammu and Kashmir, the Act was implemented across India in October 2001. The Energy Conservation Act 2001 establishes guidelines and regulations for various sectors, including industries, commercial establishments and households to adopt energy efficient technologies and practices. The Act also encourages the implementation of renewable sources of energy to reduce dependency on fossil fuels and mitigate environmental impacts. Through its provisions and incentives, the EC Act 2001 plays a crucial role in fostering a greener and more sustainable energy landscape while driving economic growth and energy security. The Government of India set up Bureau of Energy Efficiency under Ministry of Power on 1st March 2002 under the provision of Energy Conservation Act 2001. The powers of the central government under the proposed legislation are: first one is norms and standards. The central government is empowered to specify the norms and energy consumption standards for various equipments, appliances or systems that consume, generate, transmit or supply energy. Next one is description. It can designate specific equipment, appliances or classes of them that all fall under the scope of the proposed legislation. Third one is mandatory conformance. The central government has authority to prohibit the manufacturer, sale, purchase or import of equipment or appliances that do not conform to the prescribed energy consumption standards. Then labeling requirements. The government can direct manufacturers to display specific particulars such as energy efficiency ratings or other relevant information on labels attached to the equipment or appliances. The Ministry of New and Renewable Energy is the nodal ministry of the Government of India and all matters relating to the new and renewable energy. In 1982, the Department of Non-Conventional Energy Sources, that is DNES, was established under the Ministry of Energy. Then in 1992, DNES transformed into the Ministry of Non-Conventional Energy Sources. Finally, in October 2006, the ministry was renamed as the Ministry of New and Renewable Energy, that is MNRE. Its primary objective is to accelerate the adoption of clean and sustainable energy options to meet the growing energy demands while reducing the country's dependence on fossil fuels and mitigating environmental impacts. The national bodies under MNREs are Indian Renewable Energy Development Agency, that is IREDA, National Institute of Wind Energy, that is known as NIWE, National Institute of Solar Energy, NICE, Solar Energy Corporation of India, that is SECI, and Sardar Swarn Singh National Institute of Bioenergy. The Energy Conservation Act 2001 mandates creation of two-tier organizational structure to promote the efficient use of energy and its conservation in the country with Bureau of Energy Efficiency as the nodal agency of central level and state designated agency as nodal agency at state and union territory level. The Bureau of Energy Efficiency aims to enhance the institutional, technical and the financial capabilities of state designated agencies to facilitate energy efficiency initiatives at the state level. By offering financial assistance, BEE supports the SDAs in coordinating, regulating and promoting the efficient use and conservation of energy. Here we can see the different SDAs in the map of India. All 36 states, union territories have nominated as SDA in their respective state and union territories. These agencies differ from state to state, with 16 states designating Renewable Energy Development Agency. The study of fundamentals of energy science encompasses a comprehensive understanding of various aspects related to a global and Indian energy scenarios. It investigates into the exploration of current energy challenges and concerns in power generation. Additionally, the course introduces learners to the empire of alternate energy resources, including renewable energy sources like solar, wind, hydro, biomass and geothermal energy. Emphasis is placed on exploring new emerging technologies that promise to transform the energy background. The curriculum also highlights the prospects and remarkable achievements of renewable energy in addressing environmental concerns and sustainability. Learners gain valuable insights into how renewable energy technologies have contributed to mitigating climate change, reducing carbon emissions, and nurturing energy independence. This we will study in upcoming modules. Dear learners, in this first introductory module, we learned the basics of energy, its types and broad classification with their examples. We learned the fundamentals and units of energy also. We have covered the Energy Conservation Act 2001 and its salient features. We also explored the national governing bodies, that is Ministry of New and Renewable Energy. We came to know that Bureau of Energy Efficiency is working as a central body for energy efficiency program implementation, and Indian states have separate state nodal agencies for energy conservation activities. As we conclude today's introductory module, it is essential to remember that embracing renewable energy and sustainable practices not only benefits our planet, but also ensures a healthier and more flourishing future for generations to come. East or west, going green is the best. Let us all take a collective step towards a greener and cleaner tomorrow, for there is no planet B. Let's go green today, for it is the only way forward to preserve the beauty and richness of our one and only planet Earth. Thank you.